All right, section 5.3, we're going to solve polynomial equations. So we're going to solve things that have higher exponents than just x squared or x. So x to the third power, x to the fourth power. How do we solve these? Well, the first two examples are solving by factoring. So the first thing we need to do when we solve for factoring and use the zero product property is our polynomial or quadratic or whatever we're working with needs to be set equal to 0. So I'm going to bring the 4x over. So it's 4x cubed minus 6x squared. Bringing it over makes it negative 4x equals 0. Then I'm going to take out the GCF. GCF, greatest common factor. And BT dubs, my ankle just popped and it feels so much better. Oh, my ankle's been stuck all day. It's like magic. And since that happened, we'll do a little magic spinning in there. Okay. So I'm going to take out the GCF. All of these are even. That means they're all divisible by 2. And they all have an x. They're all divisible by x. So we're going to take out the GCF first. And that would leave 2x squared minus 6x. No, not 6x. 3x. And minus 2. So this times this makes this. This times this makes this. This times this makes that. So we're good. Now we're going to factor it again. So we got 2x, I make my two parentheses here, and we get 2x and x. 2x and x makes 2x squared. And then this is a 2. And that 2 needs to be negative, so that makes negative 4x, and then plus 1. So negative 4 plus makes negative 3 equals 0. Now I do zero product proper super t. All right, super t. So set each factor equal to 0. And so instead of solving the big complicated thing, we get to solve the little baby things, the things that are now set equal to 0. So I divide by 2, and I get x is 0. I subtract 1, and then divide by 2, and I get x is negative 1/2. And then I add 2 over, and x equals 2. So instead of solving one big equation, I'm solving 3 little baby equations. But I get my 3 answers, my 3 zeros of the function, my 3 x-intercepts, my 3 roots of the equation. The next one I'm going to solve by factoring as well. In fact, that's so special. It's worth a spin. All right. Then we're going to look at the next one by factoring as well. So factor. 2 sets of parentheses, put in x in each. Well, that would be a lie. We have to put an x squared in each, because x squared times x squared makes x to the 4th. And then this one here, 2 and 4, will make the 6 in the middle. So plus 2 plus 4. 2 times 4 is the 8, and then the 2x squared and the 4x squared makes the 6x squared in the middle. Then I do zero product proper t. Not a super t, just a regular t. Now I'm going to solve using my basic algebra skills. I'm going to subtract over the 2x, so I get x squared is equal to negative 2. Subtract over the 4, I get x squared is equal to negative 4. Then I can take the square root of each side. So I'm using the square rooting technique. I don't need the quadratic formula, right? Just take the square root of each side. So x equals, don't forget the plus or minus, take out the negative, I radical 2, and then this would be x equals plus or minus, square root of 4 is 2, and then the negative represents the I, so it's 2i. So there really are 4 solutions to this. I'm going to emphasize those 4 solutions. They are 2i, x equals negative 2i, x equals I radical 2, and x equals negative I radical 2. So there are 4 solutions, and it's kind of important to point out that if you have x cubed, right, we get 3 solutions, and x to the 4th yielded 4 solutions. That's kind of like a big deal in algebra that it works out that way. So each one of these would, if you plugged it back in and you had the patience to figure out how to multiply the i's and stuff together, these are solutions to this equation. They're all 100% imaginary solutions, but they are solutions. They make the algebra sentence true, even though they're complex or imaginary solutions. All right, here comes the next one. So again, we're going to set this equal to 0. 2x cubed plus 54 is equal to 0. Now there's a common factor of 2, so I'm going to divide everything by 2. And we get x cubed plus 27 is equal to 0. Now this is the factoring pattern. It's a new factoring pattern that you haven't seen before. And it's the sum of two perfect cubes. So the sum of two perfect cubes will factor. And the difference of two perfect cubes will factor. So I'll write those two formulas down and we'll use them. Here's the sum one first, is equal to a plus b, a squared minus, almost blew it there, a minus ab plus b squared. So that's the factoring pattern for the sum of two perfect cubes. All right, the difference also factors, and I'm going to put that above here because we're going to use this one. See how it matches something cubed plus something cubed. And then the difference between two perfect cubes factors into a pattern as well. A minus b, it's like the same thing, but the signs flip-flop. Okay, so you got the sum and difference of two perfect cubes. So I'm going to identify what is being cubed here. So A is what is being cubed. What times what makes this? Well, x does. And then B is what times what makes 27, and that's 3. All right. So these go into here. So it's x plus 3, x plus 3. So it's x plus 3 is my A and my B. And then it's going to be x squared, so it's a squared. And then minus a times b is these two multiplied together. That's 3x. And then b squared would be 3 squared, or 9. So this is how this factors. If you FOIL this back together, it's not really FOIL, but if you multiply, distribute this all back together, it will, all the middle junk will cancel out, and you'll just get this. So I plugged in a here and b here, and then x there squared, a times b with a negative in front, and then 3 squared. Now, this doesn't factor, but I do zero product proper t. So it's x plus 3 equals 0, and then x squared minus 3x plus 9 equals 0. All right. So usually what I usually say something like, hey guys, I'll solve this side, you solve that side. I'm done, why aren't you done? Well, we're going to use the quadratic formula on this. 1, b is negative 3, and c is 9. So this a goes into this formula, but these a, b's, and c's go into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So double negative would be 3 plus or minus square root over 2a. It looks like a 9. It's 2a. Would be 2. b squared would be negative 3 squared minus 4 times a is 1 times c is 9. All right, so we have to make sure that we get this figured out correctly. That would be 9, and that would be minus 36, which would be negative 27. Then I grab my red pen, and I split this up into 3 things, like a good math student does, negative 1, 9, and 3. So my final answer is, whoops, I want to use pencil. Be consistent. Pencil equals 3 plus or minus 3i radical 3 over 2. So these are my 3 solutions, right? I have 1 real solution and 2 imaginary solutions, but I still have a grand total of 3 solutions. This solution is a real pain because you got to do the quadratic formula on it. But this solution right here is pretty straightforward. But how did we do this? We still factored. In fact, all of these we did by factoring, right? So we factored. That was basic factoring from like last chapter. This was factoring for the last chapter, but this is new factoring. Okay, we had to use this factoring pattern to figure out how to factor this. And then we set each factor equal to 0. This dropped down. This had to be solved with the quadratic formula. Yuck. And I think that we need to reward ourselves with some spinning for that. All right. So good job, us. We found the 3 solutions. This solution and these 2 solutions here.